Hello to everyone. Good afternoon. And thanks for being here. Let me present my team. I'm Raúl Aragonés. I'm one of the co-founders of Alternative Energy Innovations based in Barcelona, Spain. My colleague David Comellas, he is the CEO, the general manager of our company, and Teresa Márquez, that she is our environmental engineer. And we have a very interesting discussion about what is the role of the heat of the industry in the 21st century, and how to use this heat of this industry to become more sustainable, okay? So, let me introduce the experiences in thermoelectricity and climate action. Here's basically, I'm showing the headlines of this presentation. First of all, heat is energy, and how to take benefit of this. And we will do this, making a little demonstration about how works that thermoelectricity. Then, we will introduce our solution, because these equipment, you will see, are basically funded by private investors and the European Commission and the Ministry of Economics of Spain. We are taking benefit of this heat to create clean energy that is returned to the grid of the company, and then this waste heat is also usable to power a new era of IoT devices for the Industry 4.0. Well, heat is energy. Let me show you a demonstration. So please, Teresa, let's show you how we convert the heat of a process. This is more or less a hair dryer, okay? And we will apply heat to this thermoelectric device. I will explain later what is the technology base of the thermoelectricity, but just applying a heat source to this solution, we can generate enough energy to move this fan, okay? Voyager spacecrafts. NASA Propulsion Laboratory, in 1977, they planned to power a new era of deep space spacecraft. So they try to explore deep planets so far away from Mars in order to analyze what was happening in Saturn, Jupiter, and Pluto. So the only way to power a big spacecraft like Voyager spacecraft was not using solar panels, because when you're far away from Mars, the sun is just a dot in the sky. So you cannot harvest any kind of energy from the sun. So the only way is to use, in this case, a thermoelectric generator. In this case, this unit generates energy from a heat source. In this example, it was basically a plutonium heat source of 1000 degrees Celsius and the 0 kelvins of the outer sky. Well, we are not using plutonium, absolutely. We are using the heat of an industry. But this equipment that you can see here, this is the thermoelectric generator. You will see later several similitudes with our waste heat converter. But with this, from 1977 to now, there have been launched 63 deep space missions. The last one was sent by the European Agency of Space. It was called New Horizons, and give us beautiful pictures of Pluto and the smallest space planet of our solar system, that is the Ultima Thule. Okay? So 63 space missions, and we said, why not to use the same principle that works in the sky, but for the industry? But the question is, why we haven't heard before of these solutions here in the industry? Well, we can see here our planet, the Earth, 4.8 millions of years of evolution, of words, of love. Everything has passed here. So let me go back in the time and analyze what has been the origin of our Earth. Initially, our Earth was not able to give life to anything, very bad weather conditions, where the life has no opportunity to survive. Later appears the deserts, also not suitable for life. But then the life as we know nowadays appears, and people take care of themselves, living in caves, dominating the heat, making tools for surviving, inventing the wheel, for example, being artists. Also, we began to make farming. Also, we began to make, how do you say that, David? Stock breeding, okay? We organize ourselves living in communities until appears the Industrial Revolution. And this was more or less 150 years ago. So, more or less, thousands of years living in the same conditions until appears the industrialization. That gave opportunities to humans to go to the industry. We can manufacture anything. Everything is possible to be created by our hands and thanks to the steam. Also appeared the massive production of cars. Anybody can take at his home a beautiful car to move. So it seems that everything was possible. We can be very creative in the way to consume goods and services, and the richness appears everywhere. So everything seems to be possible. But in the last 70 years, the global population has multiplied by 3. So there is the same opportunities to access to these goods and services to all the population. For example, if you pay attention to Asia or to Africa, the level of increase the population has been explosive in these last 30, 40 years. So, but why we haven't heard before about this way to generate power? Well, this is what is happening now. So to manufacture all the things you buy every day in Amazon, somebody has to produce them. So we need big amount of energy to create everything, to transform raw materials into final processed products. If you pay attention about the global energy needs worldwide, there is a big increase in energy demand just for give attention, to give solution to this high demanding of products of this new population that is appearing. In this map, you can see this year all the power plants of coal that are active. You see, for example, in US and Europe, in dark gray, in gray, these are the power plants that are going to be closed this year. So you will see now in the next slide how Europe is decarbonizing. Basically Poland, Germany, also Spain, and also US. But please pay attention to India and to China. Look, this is 2018. This is 2020. So in purple are the new power plants that now are being manufactured to give this energy that these countries need to have to give our same conditions of living like European or American citizens. So they need this opportunity like us. But what is the cost of our planet? It's creating, manufacturing more and more and more power plants. This has a direct impact in the carbon emissions. So more energy needs is easily translated using fossil fuels is the direct translation into carbon emissions. So this data is not decreasing. So, what is the direct consequence of this? You know, in one hand, the drying of, in this case, of the Pupu Lake in Bolivia. For example, millions of plastics put away everywhere. This data is real. So the Great Pacific garbage patch, it's twice the dimensions of the Texas state in US. That is the second state bigger in US. This is the big garbage that is floating in the Pacific Ocean. This is happening now. This is our way of consuming that has its impact. So GHG emissions, plastic emissions, that in rivers and sea. And why not? Your individual contribution, your of the ice melting of Arctic is 30 square meters per year per people. So 30 per people. And this data is more exponential in US and Australia, that is 50 square meters of Arctic ice melted yearly. That means that in the last 50 years, we have lost more or less 40% of the Arctic ice. And this has direct consequences in the sea rise level, you know. Well, this is a thing that is obvious. So we are using a space solution to give solutions for the industry. So until that moment, when the fossil fuels was the only way to increase the wealth of the world, this was the unique opportunity to do that, to generate this energy. But now that we are decarbonizing, why not to use alternative energies to give this new opportunity to this other energy that are typically called energy harvesting technologies? In our case, you know that all of these contributions makes a little, makes a mickle. So all of them, in the way, contributes to reduce dramatically the energy consumption and to become more environmental friendly. Let me show here our first approach. This is called the waste heat recovery unit. This is how AEInnova, Alternative Energy Innovation, see the future of big industries to become more energy efficient. You have to think, a very important number, that what is defined as energy intensive industries are basically industries that are more or less iron and steel industries, concrete cement industries, glass and ceramic industries, oil and petrol industries, petrochemical, chemical industries, wood industries, paper industries, food industries. So all of these industries that need heat to convert the raw material into a final product. These industries lost more or less 2/3 parts on their energy consumption in form of heat. And this energy is lost finally. It is evaporated to the atmosphere. Just in Europe, this energy lost has a direct consequence. So a 1/5 part, the 21% of the European energy needs are lost in form of waste heat, of industrial waste heat, of this industrial. So why not to try to recover part of them to generate clean energy? So our approach consists on creating a new device that can be installed, for example, in a chimney, in the face of a furnace, to any hot surface where we can harvest heat, and a part of this heat, more or less, from the 5 to 10% of this heat, can be converted into clean and negative carbon energy. In this example, in 2016, this equipment was installed in a Volkswagen plant in Spain. We cut this chimney in the painting room, and we installed a ring of 12 waste heat recovery units. We generate 30 watts per every module. So more or less 350 watts of power generation. Until this moment, the heat was just evaporated in the sky. From this point to now, we are generating energy from this heat of this pipe. This project now is co-financed by the European Commission LIFE program, LIFE 16 Environmental ES 344. So the European Commission is investing in energy harvesting because they consider that this is a big opportunity to become more energy efficient. We are making now several projects in this LIFE project program where we're installing waste heat recovery, for example, in the left, in the food sector. This pilot has been installed in Bodegas Miguel Torres, a winery, one of the biggest and more sensible industry winery in the world with the climate change. In this case, we're generating 150 watts in this demonstrator. In the middle and in the right, there will be installed in this 2020 5 more pilots in distiller, a big chemical plant in Spain. In Celsa Group, the second biggest stakeholder in iron and steel foundation, to harvest heat from the casting machines. In Goma Camps, one of the most popular Spanish paper manufacturer. So we're going to harvest heat from the smokestack. So Miguel Torres, distiller, Celsa, and how they work. Look, in the right, you see the equipment. So it seems to be, so you substitute a segment of a chimney by this equipment, and you generate 200 watts of power from the heat of the process. The same in the middle. Maybe you remember when I was speaking about Voyager spacecraft, the thermoelectric generator, right? It seems to be the same. So it's the same approach. So in the middle, we have the heat source, where we are harvesting the heat, and thanks to international patent that calls alternative energy innovations, we can generate power from this, and we can reduce up to 3.4 tons of carbon emission yearly. And then, what is the approach to power a new generation of industrial IoT devices? From my point of view, this is a very important contribution to the Industry 4.0. Let me pass to my colleague, David Comellas. He will explain. Thank you.
Thank you, Raúl. Hi, everybody. My name is David Comellas. I'm the CEO of Alternative Energy Innovations. I will speak with you about the Industry 4.0. As you probably know, we are now in the 4th industrial revolution, and all it's about digitalization of the big industry to be more efficient, to become more efficient. So in this digitalization process, you will see a scenario where the smart production, the real-time big data, customization, advanced data analysis is very important for the Industry 4.0 operation to reach the SDG goals like the renewable energy, climate action, innovation and infrastructure, and also responsible consumption. We are focused on growth in the industry, but sustainable growth. A part of this Industry 4.0 is the IoT, the Internet of Things, the Industrial Internet of Things. Why? Because the traditional wiring systems in the industry are based on wires. This is a very expensive system. It's also not really flexible and needs a high investment. The IoT allows that industry can install sensors everywhere in the process and get the data after in the cloud to process it in a very easy way. But IoT needs power, and this power came usually from batteries. Batteries, lithium-ion batteries, will be a big, huge problem for the environment during the next years. And I will explain you why. When you have a big grid of battery sensor-powered systems in the industry, means that this battery get drained. You have to change the battery every 1 year, maybe every 2 years. That means on one side a huge cost for the industry. On the other side, it means that you have a lot of waste in lithium, batteries that have to be recycled. The real thing is that most of them are just wasted to the environment. Also in the production of the batteries, you have a big environmental impact. Lithium and the other materials in the batteries are really a big problem for our environment. Just let me show you this video, I hope it works, explaining why lithium is a problem. No sound.
Throughout history, Salar de Uyuni has been little more than a popular destination for tourists and photographers attracted to its endlessly white landscape. However, in the late 1980s, everything changed, and it seemed as if the entire world wanted a piece of this salt flat. That's because Bolivia's Salar de Uyuni contains millions of tons of lithium reserves. The demand for this resource has skyrocketed over the last few decades after it was discovered to be an efficient way to build batteries. Compared to other materials, lithium can store lots of power in a tiny space, making it ideal for cell phones, laptops, and electric or hybrid cars. This would seemingly be a boon for Bolivia, a country that is both South America's poorest in per capita wealth, but richest in lithium. Bolivia is by far the largest part of the so-called lithium triangle, a collection of salt flats that also stretches over neighboring Chile and Argentina. These two countries have seen huge financial benefits from lithium extraction. In the summer of 2016, one Argentina-based contractor sold the resource for $20,000 a ton, double its usual price. These companies have also brought jobs to local indigenous communities. At the same Argentinian firm, more than half of the employees are indigenous people. But big business comes with major drawbacks. Mining sites pollute the air and contribute to global warming, and extracting the resource requires as much as 500,000 gallons of water per ton of lithium. In Chile and Argentina, water shortages already exist in many mining areas, and local communities worry that extraction will eventually run the region completely dry. Beyond pollution and drought, no one is certain what the long-term effects of lithium mining will be. Many indigenous people fear that when the salt flats eventually run out of lithium, local communities will be left with nothing. No jobs, no water, no resource-rich land.
Okay, but not only lithium are in the lithium batteries. You can find there other materials, like for example the cobalt. And why is cobalt also a problem? You can see that here.
The kitchen in somebody's house. It's now the entrance to a tunnel that goes deep underground. These men have to be careful as they descend, holding onto small ledges on the sides. What they're after is one of the rarest metals found on Earth, cobalt. And the Democratic Republic of the Congo is the source of more than half the world's supply. Much of it comes from hand-dug, artisanal mines like this one, some up to 60 meters deep. Cobalt is used in the production of lithium-ion batteries, the sort that power your electrical devices, like smartphones and laptops, and also the batteries in electric cars. But these miners, who are too poor to own laptops or smartphones, risk their lives for those who want them.
Over the past year, there have been at least 80 fatalities in these mines. But we also spoke to people who said that many accidents aren't reported, and bodies are just left buried underground.
They don't have any basic tools, safety equipment, or protective clothing, nor do they wear face masks to save them from a near-invisible poison.
Inhaling cobalt dust can be extremely dangerous. It can cause a fatal lung disease called hard metal lung disease.
It involves long hours and back-breaking labour for little reward, and for many, it's the only employment around.
Bon, quant à moi, je suis élève. Cette année, je suis à l'école. Je n'ai pas de l'argent. C'est pourquoi je l'ai fait pour avoir quelque chose pour retourner à l'école. Bon, quand je gagne un peu, je mets petit à petit. Parce que c'est une année de maquis. Après tout cet argent-là, je vais partir avec l'école.
This is the neighbourhood of Kazulo, in Kawezi City, in the south of the DRC. Residents discovered cobalt here in 2014 and have since hand-dug hundreds of holes in the ground.
These mines are extremely dangerous because These miners aren't getting any support from the government. They don't have technical training. There aren't supports within these mines.
This region has the potential to be one of the world's richest mining areas. There are dozens of large industrial copper and cobalt mines, but most people live in poverty and scrabble around for a living. It isn't only adults who dig for cobalt. So too do children, earning as little as $2 a day, and they are ripe for exploitation.
The United Nations, which is based in the DRC, says that there are at least 40,000 children working in these artisanal mines in the southern part of the country. How many are working on cobalt as opposed to other minerals, we don't know, but it's clearly a very large problem.
So, why not offer the industry a solution to avoid the waste of 25 million of lithium batteries daily? We have a proposal for the industry. It's called Indua, the Industrial Eye. It's the first battery-less IoT system in the market, and it's powered by the waste heat present in the process. The principle is easy. We gather the temperature from the process, we place the sensors, and then we process data and we send it to the cloud to give the industry the data, wireless and without the batteries. This system is tested. It's a very awarded system with more than 10 international and national awards, and is tested in big industry. This is an example in a big oil refinery in the south of Spain. We are monitoring the vibrations in a big gas compressor, and we are using the heat generated by the compressor to power the system. That means that we can power the system 24 hours, 7 days a week without using electricity from outside, without using batteries. We have also other pilots tested. This is in another oil refinery south of Spain from Cepsa, in hand of Vodafone. It's more or less the same principle, but in this case we send the data using 5G infrastructure. We have also more pilots to test it. This in a power plant, in a coal power plant, using the heat generated in the electrostatic filters where the ashes are filtered. So the system is tested very close to market. This is another case to detect steam leaks. Steam leaks are a big issue in the industry. It costs a lot of money, and this has also a big impact in CO2 emissions. Finally, main benefits of the system compared with battery systems. We can compare 10,000 batteries, generate 101,000 tons of CO2 in its production. They use a lot of water for the production. They use also a lot of electricity in the production. That means that you have to generate electricity and you have also consumption and emissions of CO2. Our Indua, after the LCA study, we only use 1.733 tons of CO2 compared with the lithium batteries. We also use less water, we also use less energy. That means it's a clean system, not only in the operation, but also in the production. And the future of the IoT and the self-powered IoT systems is here. AEInnova is participating in a big consortium of European universities to develop the next generation of IoT devices in this size, 1 cubic centimeter. The actual size of the device, I don't know if I have a device here, no, maybe yeah, there, okay. You can see it's heavy, it's 17 centimeters long. The next generation is 1 cubic centimeter, and it's enough to power the IoT device, to send data and to process it. And after all, I will, thanks to my colleagues in the company, this is AEInnova, 15 people working there, 4 PhDs, 10 engineers and 3 in finance business, 17 now, 17 people. We had a lot of public grants to develop the basic technology, and we had a lot of awards. We hope that we can decarbonize the industry, that we can help the industry to be more efficient and more environmental friendly. And yeah, just as a conclusion, it's just very easy. We recycle paper, we recycle plastics, we recycle glass, I hope. Why not recycle energy? This will be the next step. Thank you. And if you have questions, please feel free to ask. No questions?
No, let's wait.
Great. That's great. Thank you.
So this technology, the Indua, is ready in the market. So it has passed the certifications to be in the market in this November. So we are now making projects in the European industries. The waste heat recovery unit, these are big equipment that need more time to achieve the market in order to reduce the payback of the solution. We expect to arrive at the end of 2020, but the solution is going to become, from our point of view, and also from the point of view of the European Commission, a next step of the energy efficiency of big industries, and the next step in the industrial IoT. So billions of IoT devices will not have lithium batteries thanks to this solution. So if you have any question, you're free to do that. Okay, thanks for your time. You have one? Okay. Where is the microphone? Here. Okay, thank you.
Hi. My name is Yana. I come from Mexico.
Hi.
And I would like to know whether this system could be used for the companies on energy production to make it more sustainable. Or how far can it go? Like not only using this heat for the company, but maybe for some houses nearby or something. I would like to know how much energy can it produce.
Contesto yo? Yeah, so it's very easy. You have to imagine, you can compare the system to the solar, the PV solar, yeah? Each unit, it's a modular system, so each module generates energy. And you can use the energy directly in the industry for the process, or you can inject it into the grid. So you can do the same than with a big solar infrastructure. So the benefit is not only for the industry, it's also for the environment all around the industry. So we compensate the electricity. It's more or less the same principle, so it's easy to take a benefit of that.
The contribution is that if you compare the energy production of a solar PV with the same dimensions of thermoelectric generator, 1 square meter of solar PV generates more or less 40 to 50 watts of energy. So 1 square meter, 40, 50 watts of energy, where the same dimensions of 1 square meter of this thermoelectric generator generates from 300 up to 1 kilowatt of energy. So this solution is dramatically more powerful compared to the solar PV, but now it's a question of payback, so the material cost. You can see the similar approach in 1980s. A square meter of PV, a 1 watt of PV cost 200 euros, and now, 30 years later, 1 watt costs half an euro. So the thermoelectric generator, thermoelectric materials are following the same approach of cost downsides. So we expect in 2-3 more years to have very low cost materials and to make this solution affordable for all the industries. Okay? Thank you.
And there? Yeah. Al final les llencen.
What is the incident power for it to generate 1 kilowatt of energy? What is the incident power on the 1 meter square surface area?
So for generating 1 kilowatt of energy, we need more or less 600 degrees Celsius of thermal exposure. So with this 600 degrees Celsius, imagine, for example, the wall of a furnace, for example, of the cement, the concrete. With this temperature, we generate 1 kilowatt of energy. So now there is a limit. There are several materials that now they are in the research process that can achieve up to 1000 degrees Celsius, because the power generation of this material is quadratic with the temperature. So duplicating the temperature you multiply by 4 the power generator. So the best industrial energy markets are those that have a lot of temperature in the process, like iron and steel, like ceramics, that they are working more or less at 1,200 degrees. So in these markets, where the heat is enormous, the power generation can be impressive. In these others, where the temperature is quite low, the paybacks goes higher. So the payback is in inverse proportional with the temperature. The same material can reduce the payback of the solution by 4 by 8, just of a question of the temperature.
And regarding to the low power range, for example, to substitute the lithium batteries, the system works from 50 degrees Celsius. So with very low temperatures in the process, we generate enough energy to power the IoT system. So we have the whole range of temperatures, from the very low temperature generation to the very high temperature generation.
Right. Because these low power IoT devices need few energy. And with 50 degrees Celsius is enough for us to generate energy for measurement and sending data.
What efficiency does that correspond to?
Okay. Wow. Nowadays we are working with efficiencies between 5 and 10%. This is not as high as other systems like the big turbines or so, but it's far enough for the proposal of the technology. We expect in the next 5 years to reach more or less 15% of efficiency in this system.
So I have to think that compared, for example, to runtime machines that are highly complicated in the facility and moving parts and maintenance, this equipment is free of maintenance. So you plug and play. For example, in a big oil refinery, you can power any kind of subsystem in the isolated parts of the facility. So you have the heat in this part of the process, you install the module, you generate 30, 50 watts, and with this energy you can power, for example, a PLC, an electropulp. So you can generate isolation power generators in any kind of the power of a facility. This is, I think, it's a big opportunity to big industries where they have big facilities and the cost of wiring everything is highly. Okay? Okay, thanks for your time and thanks for your attention.
Thank you.
Have a nice day.